Okay, hello guys, welcome back to another episode. Today I've got three sort of things I want to get done. So I mentioned last time we wanted to add parentheses. So we'll do that. We'll just get started with that first in a minute. I want to refactor the tokens because at the moment we're sort of just doing an object. I want to make it a class. It should stop some stupid runtime errors. And then we'll look at adding variable assignments and variable accesses. So pretty big episode today. Last time, what did we do? We added our unit tests. So these, we're gonna add some more of these today as well because we're gonna be adding some new features. So let's get started with. We're going to make a new file called token.js and we're going to make a new class called token. This is literally just like exactly the same as this object here, but it's just going to have its own name, and it's going to make like accessing the type and the value a bit more bit nicer. So token value, so it's going to take two arguments, and we'll just initialize these. And we'll export this. Cool. So now we're going to import this into the lexer. So acquire token. So there we go. Cool, so now whenever we create a new token, rather than just pushing an object, we want to actually push a new token, and we'll do token type, just do type like this. So this is basically just replacing our sort of just weird object with an actual data structure now. So that's good. Let's also add the end of file token. So, like that. Another bracket. Cool. So let's check, make sure we haven't. The lexer still working. So if we do tokens, this should work. 1 + 1, and we're getting a nice bit of tokens. Cool. Do we need to change anything in here? I don't think we have to. No, I think it's okay because we've got token type and token value, so that's fine. And evaluator, this seems like it's working fine. So, okay, cool. So that should be fine for now. This is gonna mess up our tests, I think. Yeah, that doesn't look good. Yeah, we're getting some failures. Which is, to be fair, that's to be expected because it's what our tests are currently looking for is just objects, and we need to convert these to tokens. So what I'll do on camera is I'll change a couple of them first. So if I do a find and replace, we'll do token type. We'll just replace it with nothing. So I don't want to do that. So replace. Oh, we should actually do token type comma to get rid of the comma, the colon as well. Get rid of these manually. But yeah. So anyway, so let me just do this first one first. We'll get rid of token value as well. Don't need that. Cool. And put bracket around it. So yeah, so basically you just need to replace all of our objects with actual token objects. So let's also import that as well. Require token. That's fine. Put that on the end. So yeah, so what I'll do is I'll quickly speed up the footage, go through all this and sort them out. So I'll be back in a sec. Okay, so yeah, so all of our tests now are passing, which is good. So basically all it did was swap this list of objects for list of tokens. Same thing here. Nothing too crazy, so that's a bit nicer now. Right, the next step I wanted to do was adding brackets. So let's get on with that. So we're going to need the lexer and the parser open. So first, we don't actually have a brackets token yet. So let's add that in really fast. So I've got the regex open on my other screen because I can't remember. So we'll just call this open bracket token, and then the regex will be so this, I can't remember what this character's called. The little hat with a backslash bracket, just one, and then close it. I probably should put a thing as well, a colon. So that's the open bracket. So the closed bracket is basically going to be the same. We just want to change close bracket token, but we just want to change it for a closed one instead. That looks fine. Whilst we're here as well, we'll add regex for an unquoted string. So we're going to be using that for variables in a bit. So unquoted string. Now, for now, just for simplicity, we won't include any numbers in the string. It'll just be literally just characters. So we'll just do A to Z like this. And we'll do plus as well, so we can have it unlimited. That looks fine. And also for the variables. So when we come to the variables, I'll go through it properly in a minute, but we're going to do something basically the same as JavaScript. So let variable name equal something like that. So that's what we're going to do. But yeah, I'll show you in a minute how we're going to do that. So we're going to have the assignment operator, regex, and this is just an equals sign, so same as all the other regexes like that. And that looks okay for now. Let's test this out. So we'll just go into the compiler. So we'll do show tokens, and we'll do let. Oh, so yeah, so it is recognizing that it's an unquoted string. I don't know why. Oh, it's because it's not getting to the evaluator and it prints at the evaluation stage. Okay, that's fine. Fine. So it does work. Just can't really. Actually, if I do something like do this, let. Yeah, there you go. Unquoted string. What was the other one? It was brackets. Open close brackets. So like if you do 1 plus 1, that looks good. That looks fine. Okay, cool. That's a good start. Whilst we're also here, let's add a new variable called this dot reserved keywords. Actually, no, we don't need to do that. We can do that another time. Basically, I was going to add a set in there which we can add any reserved keywords to, and then rather than just doing an unquoted string, it would actually give us one of those keywords. But let's not worry about that. It's a bit pointless for now. So what we're going to do here, we're going to handle let keyword. So we're going to do if type is unquoted string, and value is let, then we're going to do this dot tokens dot push new token with the type let keyword, and the value well, it doesn't really matter. Right, we can just do hard code the value, or we can do value itself. That's fine, doesn't matter. So yeah, so basically, when we're here, we've determined the type, we've determined the value of the word we're passing. So then we're just going to check, like, really explicitly, if it's an unquoted string and the value of its let, then we'll, rather than just pushing an unquoted string, we'll push this specific let keyword to the array of tokens. We'll also do else, and then we'll just put this inside there, and that looks good. So now if we do is saved, so if we do let, and we've got let keyword. Brilliant. So that's just some like sort of foundational work, gone a bit off topic, but now what we're going to do is we're going to use sort out brackets. So there's going to be quite a bit of refactoring here because this parsing code is a bit, well, it's a bit old now. So the first place we're going to start is this parse method. Trying to think the best way to do this. So the way our parser is going to work is we're just going to sort of think about the order in which we want to basically form our parse tree. So we're going to start with parsing. How do we want to do this? To be fair, what we can do, we can sort of do variables, because what we'll do variable assignments and handling brackets at the same time, because we're basically going to rewrite a lot of this code, especially these functions down here. So let's also check whilst we're here. So we'll check the equals. It recognizes the equals operator. So we've got let a equals 10. We've got let keyword, unquoted string, assignment operator, and number, that's perfect. That's exactly what we want. Okay, so let's start from the top. So we've got this public parse method, which is what the compiler is going to be able to call. So let's initialize an AST variable. Right. Let's first check if the current token type is equal to let keyword. So this basically tells us we have a variable assignment. So we'll do this.next token, and basically what we want to do, we want to consume the let token. So if you think about what we've got here, so we've got we're just basically consuming this, deleting it, and acknowledging that what we're about to do is going to be a variable assignment. Okay, so the next step will be AST will equal this dot, and we're going to make a new method here, so we're going to call it parse variable assignment. So brackets as well. So let's create that method real quick. So where's the hashtag? Hashtag parse assignment. And this is sort of like our first sort of entry point into variables. So we're just going to do some sanity checks. We're going to do if the current token, if the type of the current token is an unquoted string. So if you remember, we've consumed our let token, and now if we've got a correct variable assignment, then we should have an unquoted string, like down here. But we can also check, so we can use our peak. Do we have peak? Why is that not coming up? And this dot peak, don't know why that wasn't coming up. So if you remember this peak method, lets us basically get the token, any token ahead of the current token. So the offset is basically what we pass into it. So if we pass in an offset of 1, then it will look for the token after the current token. And so we want to check the token type of that is equal to assignment operator. I think I'm missing, I've got an extra bracket in there. So let's format that nicely. yeah, so if these two conditions are set, then we've definitely got a variable assignment, which is good. So let's get the variable name. Let's just consume the token. So the variable name will just be the unquoted string, not current token, this.next token, so that consumes that token, and then the identifier token equals this.next token, so we'll consume that as well. And then we want to recurse, because we could have something like let a equal b equals c equals 10, and basically that will just initialize these three variables to equal 10. So if we recurse now, then we can handle that straight away, which is nice. So we'll just call this right, because it's going to be the right hand side of the tree, and we're going to call this function again. And then at the end of it, if this doesn't return anything, then we're just going to return a new variable assignment. And this, that's not right. And this is a object that we need to create. So let's actually head over to expression types and create this. So class variable assignment extends syntax node. And this is, it's pretty similar to a binary operation, really. It's going to take a variable name, identifier token, and the value. Yeah, let's just do value's fine. And let's initialize these as well. So I forgot super as well. Fine, and then we'll export it as well. And also, whilst we're here, we'll do another class called variable access, which we won't use just yet, but it will come in handy a bit further down the line. Constructor. And then for this, what do we want? We want this, and we also want to take in the variable name. We only need the variable name for the access, so a little bit different variable name. This looks all okay. I might call this variable value actually. I think let's rename this as well. Cool. Okay, looking good. Export this other one as well. So that's good. We don't probably won't need this for a little while now. Let's keep going with this. So let's import our variable assignment we've just created. Require syntax. Oh no, we already imported expression types up here. So if we do variable assignment like that, that's fine, and it should recognize it down here. Yeah, it does. So we'll pass in the variable name, identifier token, and right. So we're just basically recursing, which is nice. That's fine. Otherwise, what we're going to do, so this will handle all of the variables. So say, for example, we've got let a equals b equals c, and then if you do a number, it's not gonna recognize it because we're not handling that in here. So we need to have this else statement. So else, we have a number, so we're gonna want to return this pass binary expression. Okay, that looks fine to me. In fact, one other thing I've just remembered actually. I'm going to add in another else if statement. The problem with our compiler is we don't have a type checker, like actually in the compiler itself. So we're gonna have to do sort of manual type checking, which is an absolute pain, and it means we're not gonna be able to make this very complicated. But you know, it's fine. It's a simple token, a simple compiler, so it doesn't matter too much. What we're gonna do is we don't want to be able to set variable names to be numbers. So basically, if for example you did something like let 10 equals 10, that shouldn't be possible because 10 is a number and you can't reassign number. So yeah, so with this current logic, we'd check these and it wouldn't pass these checks. Then it'd go down to this pass binary expression, and then it just wouldn't work properly. It just returned 10. The rest of this wouldn't be seen. So we just need to handle this little. It's like an edge case basically. So let's check the current token type, and if it's equal to number, is that what we called it? Yep, number. If it's equal to number and it's equal, the next one is an assignment operator. So peak one token type. So we're just checking the following token is an equals sign. Then what we're going to do is we're going to throw throw an error. Throw a new parser error. And we'll do a nice little descriptive message. So we'll say parser error, variables cannot be named. Let's just say variables must be strings. Variable names, that's better. Must be strings. Got, and then we'll do in curly brackets this dot current token dot token value. Token value, like that. Okay, that looks fine. So yep. I'll go back and comment all this stuff a bit later because it's a bit unclear what's going on right now. So we've been recording for 27 minutes. This is getting a bit long, so we'll do this a two-part because there's quite a lot left to do still. So thanks for watching. We'll continue with this in the next episode. It shouldn't take too long between episodes. And yeah, thanks for watching.